Hey guys, so today I'm going to show you how to use a different way to use standard error, especially if your standard error is coming up as 0 because maybe you don't have enough data in your table, etc., or FXL's not picking it up. What we're going to do is we've got our spreadsheet, we've got our graph here. We're going to press the plus button and we're going to click on error bars, and I'm just going to go here to more options. And I'm going to go to the graph function here to custom and say specify value. We're going to click on that. We're going to delete these two values here. We're going to click on the positive error value and we're going to select these 4 cells because these 4 graphs are based on these 4 cells here. And then for the next one, I'm going to select the same 4 cells for the error. Now when I press OK, because all the errors are 0, all the error bars are 0. But one of the things we can use is we can use the range divided by 2. What that means is we want to be able to take the max value and the min value and divide it by 2. So in this case over here, this is another way to be able to work out error. So if I actually say equals, what is the max? I'm going to open brackets. What is the max value? It's 8. I'm going to minus the smallest value, which is 5. I'm going to close bracket and then divide that by 2 and press enter. Okay, so what that's saying is, in my whole data set, okay, if I had really accurate data, shouldn't they all be the same or close to the same value? And the further the spread is of numbers away from the mean of those 3, there must be more error. So basically this is the top of the bar, this is the bottom of the bar, and somewhere in between there, okay, there's 3 numbers different, and so the middle part between those two is 1.5 away. Same deal, if I can now go to this one and go equals, what's the biggest number is, open bracket, is 15, and we're going to take that away, take 12 away because that's the smallest number, press open bracket, divide that by 2, the answer is 1.5 as well. So the difference in numbers between 12 and 15 is 3 values. Divide that by 2 is again 1.5. We have a look at this one, the biggest, so again equals, open bracket, the biggest value is 24 minus 20. Okay, and close bracket and then divide that by 2, and that error is 2. There is 4 numbers between 20 and 24, divide that by 2 is 2. And finally here, the biggest number here is we got 28. We're going to take that away from with 23. Obviously we're going to need to put that in brackets first, and then I'm going to divide that by 2. So now I've got those numbers, I can actually plug them into here. This is the 1.5 molar, so this is 1.5. The next one is 1.5 again. This one is 2, and this one is 2.5. So what that means is, in my assignment, this bar has the most error because it's 2.5 in size. These 2 bars had the least amount of error, and some other things to consider here is that this error, this data for this one, the top bar of the data is here, the bottom part of the data is here, okay, and it is absolutely clear. Alright, if I go down to my tool here, and if I can just draw here, that if I could draw a bar across, that is absolutely clear of this data here, which means this data is significantly different from this result and this result. And because they're significantly different, it means that the data, in a sense, it means that excuse me, that the data is clear away from each other and the data values are different, and so there is a clear difference between the two. Okay, there is a discernible difference between the 2 data. We'll have a look at this one, however. This one here is encroaching over there. Okay, And same deal, this data here, if I draw it across, there is this small overlap in here where both data from both graphs are. It's not a huge overlap, but it means that some of the data in here under the same conditions is the same as some of the data in here, which means that, if that was 24, that had a value of 24, and over here that had a value of 24. There's no difference between them, so there's no significant difference in the data, which means that maybe if we ran the experiment again, even though the bars look differently here, maybe this would be 24 and this would be 24 again between 1 molar acid and 2 molar acid. Is there that big of a difference between them? Is there enough student error to say that the amount between them is not significant enough? We'd have to rerun more trials to try and see if we can get more discernible data. Okay, and that's what that means. So if you've done that right, you've been able to work out the error and the range, and then as a result plug those in, and that's the bar with the correct data. Don't forget to change your title and your axis titles as well. Thanks for listening.